we are going to start with evidences of evolution. So before we go into evidences of evolution, you first have to understand what evolution means. So evolution is a slow, irreversible, progressive change. Basically, evolution takes place over several generations, and the changes are always in such a way that it benefits the survival of an individual to the changing environments. So once again, evolution is a slow, irreversible, progressive change. So when we talk about evidences of evolution, the first one that comes to mind is evidences from fossils. The second one is evidences from anatomy. So when we talk about anatomy, it basically deals with the organs and structures. The third evidence is from embryology. So when we talk about embryology, it means the development of embryos. The next evidence is from biomolecules. And the most common biomolecule is the genetic material, this is DNA and RNA. So basically when we study about DNA and RNA, also it gives us an evidence of evolution. And the last evidence is from biogeography. So when we talk about biogeography, basically it deals with the distribution of animals in the various geographical factors. Some animals are better suited to survive in colder climates, some animals are better suited to survive in warmer climates. So the distribution of animals in these various types of habitats gives us an example of evolution. So the first thing we're going to start is with fossils. When we talk about fossils, fossils are nothing but the dead remains of organisms. So there are many types of fossils, entire organisms, in which an entire organism is preserved, or in some cases only the occurrence of organisms are preserved. So basically the earth is made of various layers of rocks. Now remember, the rock at the lowest layer is always formed first. The second layer is formed at a rather recent time, and the topmost layer is formed at the most present time. So that means the rocks which are the lowest layers are the ones which were first formed. So depending on the fossils found at the various layers, we can easily find out how evolution took place. So when we talk about fossils, there are many types. Tracks and trails. When you talk about tracks and trails, it is a very simple example. Basically, when you're walking in the beach, what do you leave out? You leave out footprints. So footprints are also an example of tracks and trails. So earlier I told you that the rocks which are found at the lowest layers contain fossils of the most primitive organisms. So depending on this, there is a particular time scale which captures the history of the earth. That particular time scale is called geological time scale. The geological time scale can be divided into eras which are further divided into periods, and periods which are further divided into epochs. So there are various types of eras. Paleozoic, Mesozoic and Cenozoic. Again, your periods, for example, your Cenozoic can be further divided into periods like the Triassic or Jurassic periods. So basically when we talk about the Jurassic period, the thing that comes to your mind might be dinosaurs. So in that particular phase, what happens was there is a famous phenomenon which took place. That phenomenon is called mass extinction. We because in the Jurassic period you all know that dinosaurs were the most dominant organisms. But what happened is, due to the strike by a meteoroid, the entire dinosaurs they became extinct. So this particular phenomenon is called mass extinction. Clear? So now another example of evolution by the study of fossils is evolution of horse. Its scientific name is Equus basically originated from the primitive horse called Eohippus. Eohippus it again further underwent a change called Meohippus, and from Meohippus Merychippus, and from the Merychippus to the present modern day horse, that is Equus. So basically when we are studying about the evolution of horse, up to here we only have fossil records. So basically when we talk about the evolution of horse, the things to remember is the primitive horse, they were of shorter height. So that means the progressive change is increase in height. If you compare the primitive horse, that is your Eohippus, to the modern day horse Equus, there will be a massive difference in the height. Another difference is changes in the bones of the limbs. Basically there are two types of limbs, forelimbs and hindlimbs. In the forelimbs there were 4 digits, that means 4 fingers, and in the hind limbs there were 3 digits, that means 3 fingers. So what happens is, as the horses started to undergo evolution, in the forelimbs the digits got reduced from 4 to 3, whereas in the hind limbs there was still the same number of digits, that means it's still at 3 toes. Another thing you have to remember is the middle digit, it started to become longer, whereas the other 2 digits they remain the same. So over passage of time, the forelimbs and the hind limbs became modified in such a way that you basically get only 3 digits, in which the 1 digit forms the main toe. So when we talk about the evolution of horses, progressive change in height, progressive change, that means decrease in the number of digits present in the limbs. The next evidence of evolution is from anatomy. That means we are basically studying about the structure of organs. So from anatomy, you have to remember 3 main things. Homologous organs, analogous organs, and vestigial organs. By homologous organs, what it means is organs which have the same origin but serve different functions. Examples are the 4 limbs of man, that is your hand. If you compare the 4 limbs of man, that is hand, with the 4 limbs of animals, there are massive differences. But what is it? They all have the same origin. That means by origin, what it means is they have the same pattern or the same bone structure. But that is, they serve different functions. For example, in man, hands can be used to do various things like writing, eating, and whatever you want to do. But whereas in the case of animals, it's basically for locomotion. Analogous organs means organs which have different origin will serve the same function. Examples are wings of insects and birds. Both are used for flight. That means they are serving the same function, but the origins are different, because in birds the wings are modified forelimbs, but whereas in insects the wings, they are nothing but a part of the exoskeleton. That means they all have different origin. Vestigial organs means organs which were functional in our ancestors but no longer functional in the present generation. The most famous examples are appendix and wisdom tooth. So earlier in our ancestors, basically they were used to feeding on grass. So basically they might have needed an extra molar, that is a wisdom tooth, and appendix to digest the cellulose of the grass. But nowadays we no longer feed on grass, so we don't need an extra molar, that is a wisdom tooth, or the appendix. So just by studying about the organs, that is the homologous organs, analogous organs, or vestigial organs, we get a slight idea about evolution. The next evidence is from biochemistry. By biochemistry, what it means is the molecules which are present in biological organisms. So basically, when we talk about biochemistry, it's a combination of two subjects, biology and chemistry. But regarding evolution, we will be concentrating only on the chemical compounds that are found in biological organisms. And earlier I told you that the most common examples are genetic material, which are nothing but DNA and RNA. So if you compare the various organisms from viruses, bacteria to multicellular organisms like mammals or reptiles, you will always find that there is always some similarity regarding DNA and RNA. There might be major changes among unicellular and highly advanced multicellular organisms, but they will always share some sort of similarity, which proves that evolution is taking place. So basically what it means is we all have the same common ancestor which lead to the diversity of life. Another example of biochemistry can be the study of molecules or compounds present in the blood. It can either be hemoglobin or hemocyanin. So basically hemoglobin is also common amongst various animals. The next evidence of evolution is embryology. Embryology means the study of development of embryos in animals. So basically when we talk about embryology and compare the embryos of different animals, let's say man, dog, cat, what happens is at a certain stage up to let's say about 3 weeks, it's very hard for us to differentiate whether a particular embryo belongs to a man, a dog or a cat. That means the embryos up to a certain amount of time all share the same common pattern of development and certain same features. So this proves that we again all share the same common ancestor. So regarding embryology, there's one important rule called biogenetic law proposed by Ernest Haeckel. Ernest Haeckel, what he stated is ontogeny repeats phylogeny. Ontogeny means developmental history of an organism. Phylogeny means evolutionary history of an organism. So, for the bonus tackle, when we're studying about embryology, what it means is ontogeny repeats phylogeny. Ontogeny is developmental history of an organism. Phylogeny is evolutionary history of an organism. So, example is tadpole. It develops into a frog. But what happens is, as the tadpole is developing, the different stages of the larva or the tadpole, it all resembles the larva of a fish. So what this means is, during the developmental history of a frog, it is repeating the evolutionary history of amphibians, from fishes, because amphibians evolved from fishes. So during the development of a frog, that is from the tadpole, basically what you can have is a slight idea about phylogeny. That means it is giving an example of the evolutionary history of the entire organism. So that means when we are studying about the different tadpoles of the frog, basically what we are getting is evolutionary history that amphibians evolved from fish. The last evidence is from biogeography. Earlier I told you biogeography means the distribution of animals and plants. So basically when we talk about biogeography, we have to remember that previously there was only one land mass. This land mass, it broke up into several pieces leading to the various continents that you see in the present day Earth. Now, when we talk about biogeography, there's a famous example given by Darwin called Darwin's finches. Darwin's finches are nothing but a group of small birds found in the islands of Galapagos. Galapagos Islands are present near the Pacific Ocean. So basically, Darwin, what he did was he studied a set of group of birds present in Galapagos Islands. So what happens is, Galapagos Islands are a set of islands. Each island has a unique bird . The differences can be in their beak structure and color pattern. So what happens is, each bird basically originated from bird which was not feeding on insects, but due to the islands and their own geographical patterns, certain birds had to develop certain feeding habits. Like for example, bird 1, it had to feed on nuts. Bird 2, it had to feed on insects. So basically, when we're studying about different birds found in the Galapagos Islands, they all share the same common beak structure. And this same beak structure was found in the main birds that is found in the mainlands of America. So what this means is, birds from the American mainlands migrated to the Galapagos Islands. Due to the islands having their each unique geographical climate or environmental or crop production, the birds had to evolve among themselves to feed themselves. So as a result, what this means is, each bird evolved according to the changing environmental patterns. So this proves that evolution is taking place. things you have to remember. Missing links. Missing links means these are fossils of organisms which provide connecting links between two different types of animals. The most famous example is Archaeopteryx lithographica. Basically, this organism is a connecting link between birds and reptiles. Only its fossils records are found. So from this, what we can find is that this particular organism had characters common to birds as well as characters common to reptiles. The characters which are common to birds are presence of beak and feathers. But the characters which are common to reptiles are the presence of teeth in the beak. So basically, this missing link or this fossil, what it proves is that birds and reptiles, they might be somehow connected, or birds, they might have evolved from reptiles. So this is an example of missing link. Another thing you have to remember is connecting links. Connecting links are organisms which are still found in the modern day times and provide links between two different animals. The most famous example is lungfish. It provides a connection between amphibians and fishes. A lungfish, the character which it shares with amphibians is presence of lung itself. With fishes, the characters which it shares is the presence of scales in the lungfish. Another example of connecting link is ant eater. It provides a link between mammals and reptiles. Ant eater. The connecting link on mammals is there is warm-blooded. The connecting link with the reptiles is that it lays eggs. Another thing you have to remember is atavism. Atavism is nothing but a phenomenon of sudden reappearance of ancestral characters. Examples can be presence of teeth in a newborn baby or the body being covered by hair. Now, hair was a common character among our ancestors, but it's no longer present in our parents. So, there was a famous example of the lion baby of Russia. What it proved was the phenomenon of atavism, that means sudden reappearance of ancestral characters. That means this baby basically had its entire body covered with hair and had a small tail. So just to recap, evolution is a slow, progressive change taking place over various amounts of time. Evolution can be studied by taking into account the various evidences. The first one is fossils, the second one one is anatomy, the third one is embryology and biogeography and biomolecules. So if you have any problems, you can just ask me.